Mechanism of operation: electronic document production technology. The mechanisms of operating electronic materials manufacturing technology. Electronic materials are essential components of modern technology, and are used in a wide range of applications, from consumer electronics to aerospace. The process of manufacturing electronic materials involves several key steps, including material selection, fabrication, and characterization. One of the most important steps in the process is material selection. Because electronic materials are often used in applications where their unique properties are important, it is important to carefully select the appropriate material for the application at hand. This may involve considering factors such as the material's chemical and physical properties, its cost and availability, and its performance characteristics under different conditions. Once the material has been selected, the next step is fabrication. There are several different techniques that can be used to fabricate electronic materials, including physical and chemical vapor deposition, electrospinning, and lithography. Each of these techniques has its own advantages and disadvantages, and the choice of technique will depend on factors such as the material being used, the desired thickness and properties of the material, and the available equipment and resources. After the material has been fabricated, the next step is characterization. This involves analyzing the material to determine its properties and performance characteristics, such as its electrical conductivity, thermal stability, and optical properties. Characterization may involve a wide range of techniques, including microscopy, spectroscopy, and electrical measurements, as well as other specialized techniques depending on the specific properties of the material being analyzed. The mechanisms of operating electronic materials manufacturing technology are complex and require specialized expertise and equipment. However, the benefits of these materials, such as their unique properties and performance characteristics, make them an important area of research and development for a wide range of applications. In addition, advances in manufacturing techniques and equipment are enabling the production of these materials in larger quantities and at lower costs, which is opening up new opportunities and applications for electronic materials. One of the most promising areas of application for electronic materials is in the development of electronic devices, such as flexible displays and sensors. Electronic materials, such as graphene and carbon nanotubes, have unique electronic properties that make them well suited for use in these devices. In addition, electronic materials are also being used in the development of energy storage and conversion devices, such as batteries and solar cells. The high electrical conductivity of these materials can lead to improved performance and efficiency in these devices, which can have significant implications for the development of renewable energy technologies. Another promising application of electronic materials is in the development of biomedical devices and therapies. Electronic materials, such as nanosheets and nanofilms, can be used to create implantable devices and drug delivery systems that are biocompatible and have improved performance characteristics. One of the biggest challenges facing the adoption of electronic materials manufacturing technology is the need for specialized expertise and equipment. Because these materials are often highly sensitive and delicate, it is important to ensure that researchers and manufacturers have the necessary expertise and equipment to handle and manipulate these materials without damaging them. This may involve developing new training programs and certifications, as well as working with industry partners to ensure that the necessary expertise and knowledge is available. Another challenge is the need for regulatory approval and certification. Because electronic materials often have unique properties and capabilities, it is important to ensure that they comply with all relevant regulations and standards. This may involve working closely with regulatory bodies to ensure that certification and testing requirements are met, and that all necessary permits and approvals are obtained. Despite these challenges, the adoption of electronic materials technology also presents significant opportunities for various industries. One of the most promising opportunities is in the development of wearable devices. Because electronic materials are thinner and more flexible than traditional materials, they are well suited for use in wearable devices that need to be comfortable and non-intrusive. In addition, electronic materials technology can also be used to develop innovative new materials for use in energy storage and conversion devices, such as batteries and solar cells. By using electronic materials, researchers and manufacturers can create materials with higher energy density and efficiency, which can have significant implications for the development of renewable energy technologies. Another promising application of electronic materials technology is in the development of biomedical devices and therapies. Electronic materials, such as graphene and nanofilms, can be used to create implantable devices and drug delivery systems that are biocompatible and have improved performance characteristics. In addition, electronic materials can also be used in the development of diagnostic tools, such as biosensors and imaging agents, that can enable earlier and more accurate detection of diseases. However, there are also environmental concerns associated with the production and disposal of electronic materials. The extraction and processing of certain metals and minerals used in the production of these materials can have significant environmental impacts, including soil and water pollution, habitat destruction, and greenhouse gas emissions. To address these concerns, manufacturers and researchers are exploring alternative materials and sustainable manufacturing techniques to reduce the environmental impact of electronic materials. The impact of electronic materials manufacturing technology on various industries has been significant. This technology has enabled the creation of materials that are thinner, lighter, and more efficient than traditional materials, while also offering improved performance and flexibility. In addition, electronic materials technology has the potential to revolutionize the way that we think about materials. By enabling the development of new materials and opening up new applications and markets. One of the most promising areas of application for electronic materials technology is in the development of electronic devices, such as flexible displays and sensors. Electronic materials, such as graphene and carbon nanotubes, have unique electronic properties that make them well suited for use in electronic devices. These materials can be used to create flexible displays and sensors that are thinner, lighter, and more energy efficient than traditional electronic devices. In addition, electronic materials are also being used in the development of energy storage and conversion devices, such as batteries and solar cells. The high electrical conductivity of these materials can lead to improved performance and efficiency in these devices, which can have significant implications for the development of renewable energy technologies. Another promising application of electronic materials is in the development of biomedical devices and therapies. Electronic materials, such as nanosheets and nanofilms, can be used to create implantable devices and drug delivery systems that are biocompatible and have improved performance characteristics. In addition, Electronic materials can also be used in the development of diagnostic tools, such as biosensors and imaging agents, that can enable earlier and more accurate detection of diseases. However, there are also challenges associated with the adoption of electronic materials technology. One of the biggest challenges is the cost of production, which can be high due to the use of specialized materials and manufacturing techniques.
How electric vehicle manufacturing technology works. As the world becomes more conscious of the impact of fossil fuels on the environment, there has been a growing interest in electric vehicles, EVs, as a more sustainable mode of transportation. The production of electric cars involves a combination of advanced technologies and innovative manufacturing processes that differ significantly from those used in conventional automobiles. In this article, we will explore the workings of the manufacturing process of electric cars. The production of electric cars starts with the battery, which is the heart of the vehicle. The battery is made up of individual cells, which are linked together to form a battery pack. In most cases, the battery pack is placed beneath the car floor to keep the center of gravity low and improve stability. The battery cells are produced using advanced manufacturing techniques, which involve coating thin strips of metal with active materials, such as lithium or cobalt, and then rolling them up like a jelly roll. Once the battery is complete, the next step is to assemble the powertrain. The powertrain is the combination of components that generate power and transmit it to the wheels. In an electric car, the powertrain consists of an electric motor, a power electronics module, and a transmission. The motor is responsible for converting electrical energy into mechanical energy, which is then transmitted to the wheels via the transmission. After the powertrain is assembled, the next step is to build the car body. The body of an electric car is typically made of lightweight materials such as aluminum or carbon fiber, which reduces the overall weight of the vehicle and increases its range. The body is produced using advanced manufacturing techniques such as stamping, welding, and bonding. Once the body is complete, the final step is to assemble the car. This involves installing the battery, powertrain, and other components such as the dashboard, seats, and infotainment system. The car is then subjected to a series of tests to ensure that it meets all safety and quality standards. One of the key benefits of electric car production is that it produces less waste than traditional car manufacturing. This is because the production process involves fewer parts and components, and many of the materials used in electric car production are recyclable. In addition, electric car production creates fewer emissions than traditional car manufacturing, as it relies largely on renewable energy sources such as wind and solar power. One of the significant differences between electric and traditional cars is the way they are powered. While gasoline-powered cars rely on internal combustion engines, electric cars use electric motors powered by rechargeable batteries. The electric motor generates torque and power, which is then transmitted to the wheels, propelling the car forward. The electric motor is powered by a rechargeable battery pack, which is a collection of individual battery cells connected in series or parallel. The battery pack can be charged using a standard electrical outlet, a dedicated charging station, or a fast charging station. The range of an electric car depends on the size of the battery pack and the efficiency of the motor. Another critical component of electric car technology is the regenerative braking system. When a driver applies the brakes in a gasoline-powered car, the kinetic energy of the car is converted into heat and dissipated into the atmosphere. However, in an electric car, the kinetic energy is converted into electrical energy and stored in the battery pack through regenerative braking. This system helps to extend the range of the car and reduce wear and tear on the brakes. The power electronics module is another critical component of electric car technology. It controls the flow of electrical power between the battery pack, the electric motor, and other electrical components of the car. The power electronics module also regulates the charging of the battery pack, ensuring that it is charged safely and efficiently. The charging infrastructure is another essential aspect of electric car technology. As more people switch to electric cars, there is a growing need for charging stations to be installed in public places, workplaces, and even homes. There are 3 types of charging stations: Level 1, Level 2, and DC fast charging. Level 1 and Level 2 charging stations use AC power and take several hours to charge the battery pack fully. DC fast charging stations use DC power and can charge the battery pack to 80% capacity in as little as 30 minutes. One of the benefits of electric cars is that they have fewer moving parts than traditional cars, which means less maintenance and fewer repairs. Additionally, electric cars are much quieter than gasoline-powered cars, as they don't have internal combustion engines. This makes them ideal for use in urban areas, where noise pollution is a concern. Another advantage of electric cars is that they are more energy efficient than traditional cars. While gasoline-powered cars are only about 20% efficient, electric cars are about 60 to 70% efficient. This is because electric cars convert more of the energy stored in their batteries into motion, whereas gasoline-powered cars waste a lot of energy in the form of heat. Electric cars also offer a smoother, more responsive driving experience than traditional cars. This is because electric motors generate maximum torque from the start, which means that they can accelerate quickly and smoothly. Additionally, electric cars have a low center of gravity, which gives them excellent handling and stability on the road. One of the challenges of electric cars is their limited range. While some electric cars can travel over 300 miles on a single charge, most have a range of around 100 to 150 miles. However, advancements in battery technology are rapidly increasing the range of electric cars. Additionally, the development of a network of fast charging stations will make it easier for drivers to charge their cars on long trips. Another challenge of electric cars is their upfront cost. While the cost of electric cars is decreasing, they are still more expensive than traditional cars. However, electric cars are cheaper to operate and maintain over their lifetime, which can offset their higher upfront cost. One of the key benefits of electric car technology is its environmental impact. Electric cars produce zero emissions while driving, which means they don't contribute to air pollution or climate change. This makes them an excellent choice for people who want to reduce their carbon footprint and help protect the planet. In addition to being environmentally friendly, electric cars are also more convenient to operate than traditional cars.
How to operate airplanes dedicated to the mining industry. Mining is a complex and demanding industry that requires specialized equipment to operate efficiently and safely. One of the key tools used in mining operations is the specialized aircraft designed to support mining activities. In this article, we will discuss the different types of aircraft used in mining operations and how they are operated. One of the most common types of aircraft used in mining operations is the helicopter. Helicopters are versatile and can be used for a wide range of tasks, including transporting personnel and equipment to remote mining sites, conducting aerial surveys and inspections, and providing emergency medical services. Helicopters used in mining operations are typically fitted with specialized equipment, such as winches and cargo hooks, to facilitate the transportation of heavy loads. Another type of aircraft used in mining operations is the fixed-wing aircraft. Fixed-wing aircraft are typically used for transporting personnel and equipment over longer distances, such as between mining sites and urban centers. They can also be used for conducting aerial surveys and inspections, and for transporting specialized equipment, such as drilling rigs and heavy machinery. In addition to helicopters and fixed-wing aircraft, mining operations also use unmanned aerial vehicles, WAVs, or drones. WAVs are particularly useful for conducting aerial surveys and inspections, as they can be flown over inaccessible or hazardous areas without risking the safety of personnel. WAVs can also be used for monitoring and mapping mining sites, and for detecting and monitoring environmental hazards, such as landslides and pollution. The operation of specialized aircraft used in mining operations requires highly trained and skilled personnel. Pilots must be knowledgeable in the specific requirements and challenges of mining operations, including flying in remote and challenging terrain, and operating in hazardous conditions. They must also be familiar with the specialized equipment and procedures used in mining operations, such as cargo loading and unloading, and winch operations. In addition to pilots, mining operations also require specialized ground support personnel, such as mechanics and technicians, to maintain and repair aircraft and to oversee the safe loading and unloading of cargo. These personnel must be highly skilled and trained in the specific requirements of mining operations, including the handling of hazardous materials and the safe operation of heavy equipment. In conclusion, the use of specialized aircraft in mining operations is an important aspect of the mining industry. Helicopters, fixed-wing aircraft, and WAVs are all used to support mining activities, including transporting personnel and equipment, conducting aerial surveys and inspections, and providing emergency services. The operation of these aircraft requires highly trained and skilled personnel, including pilots, mechanics, and technicians, who are familiar with the specific requirements and challenges of mining operations. By using specialized aircraft and personnel, mining operations can operate more efficiently and safely, while minimizing the impact on the environment and surrounding communities. In addition to the use of specialized aircraft, mining operations also rely on a range of advanced technologies to improve efficiency and safety. These technologies include satellite imaging, remote sensing, and geospatial mapping, which can provide detailed information on mining sites, including the location and extent of mineral deposits, as well as potential hazards and risks. Mining operations also use sophisticated software and data analytics tools to optimize operations and improve productivity. These tools can help to identify areas where improvements can be made, such as reducing waste and improving energy efficiency, and can also help to forecast production and demand, enabling mining companies to better manage their resources and plan for the future. Another important technology used in mining operations is automation. Automation technologies, such as autonomous vehicles and drones, can help to improve safety and productivity by reducing the need for personnel to work in hazardous or remote environments. These technologies can also help to reduce costs and improve efficiency by optimizing operations and reducing downtime. One of the key challenges in the use of advanced technologies in mining operations is the need for skilled personnel who can operate and maintain these technologies. Mining companies must invest in the training and development of their personnel to ensure that they have the skills and knowledge needed to operate and maintain these technologies effectively. Another challenge is the need to balance the benefits of advanced technologies with the potential risks and negative impacts on the environment and surrounding communities. Mining companies must be mindful of their environmental and social responsibilities, and must work to minimize the impact of their operations on the environment and local communities. In conclusion, the use of advanced technologies in mining operations has revolutionized the mining industry, enabling companies to operate more efficiently and sustainably, while minimizing the impact on the environment and surrounding communities. From specialized aircraft to satellite imaging and automation, these technologies are helping to drive innovation and improve safety and productivity in mining operations around the world. However, the effective use of these technologies requires skilled personnel and a commitment to environmental and social responsibility. And mining companies must work together with stakeholders to ensure that they are used in a responsible and sustainable manner. Another important aspect of mining operations is the management of waste and the remediation of environmental impacts. Mining activities can generate significant amounts of waste, including tailings and waste rock, which can contain toxic substances and pose a risk to the environment and human health. To manage these impacts, mining companies must implement effective waste management practices, including the safe storage and disposal of waste, and the management of water resources. They must also implement measures to prevent and mitigate environmental impacts, such as soil erosion and water contamination, and to restore and rehabilitate affected areas. One approach to the management of waste and environmental impacts is the adoption of a circular economy model, which aims to minimize waste and maximize resource efficiency. This involves the reuse and recycling of materials, as well as the development of new technologies and processes that can reduce the environmental impact of mining activities. Another important aspect of mining operations is the engagement with local communities and stakeholders. Mining activities can have significant social and economic impacts on local communities. And it is important for mining companies to engage with these communities and stakeholders to understand their concerns and to develop strategies to address these concerns. Engagement with local communities can also help to build trust and support for mining activities, and can help to ensure that mining operations are sustainable and contribute to the development of local economies. In addition to engaging with local communities and stakeholders, mining companies must also comply with relevant laws and regulations, and must operate in a transparent and accountable manner. This includes the disclosure of information on environmental and social impacts, as well as financial performance and corporate governance. In conclusion, the management of waste and environmental impacts, engagement with local communities and stakeholders, and compliance with laws and regulations are all critical aspects of mining operations. By implementing effective waste management practices, adopting a circular economy model, engaging with local communities, and operating in a transparent and accountable manner, mining companies can ensure that their activities are sustainable and contribute to the development of local economies. Inside new material manufacturing technology. The production of new materials is a rapidly developing field, with scientists and engineers constantly working to create materials with new properties and functions. In this article, we will explore the latest advancements in the production of new materials. One of the latest advancements in the production of new materials is the use of nanotechnology. Nanotechnology involves the manipulation of materials at the atomic and molecular level, allowing scientists and engineers to create materials with unique properties and functions. Nanomaterials are being used in a variety of applications, from electronics and medicine to energy and construction. Another advancement in the production of new materials is the use of bioplastics. Bioplastics are made from renewable materials, such as cornstarch and sugarcane, and are biodegradable, making them a more sustainable alternative to traditional plastics. Bioplastics are being used in a variety of applications, including packaging, textiles, and medical devices. Advanced composite materials are also being developed for use in a variety of applications. Composites are materials made from two or more different materials, combined to create a material with unique properties and functions. Advanced composites are being developed for use in aerospace, automotive, and construction applications, where lightweight and high-strength materials are required. In addition to these advancements, new materials are also being developed for use in energy production and storage. Materials such as graphene and carbon nanotubes are being used to create more efficient and durable batteries and fuel cells. While new materials such as perovskite are being developed for use in solar cells. Finally, the production of new materials is being driven by advances in manufacturing technology. Additive manufacturing, or 3D printing, is being used to create complex and intricate structures with a high degree of precision and accuracy. This technology is being used to create new materials with unique properties and functions, as well as to improve the efficiency and sustainability of the manufacturing process. In conclusion, the production of new materials is a rapidly developing field, with new advancements being made all the time. From nanotechnology and bioplastics to advanced composites and energy materials. Scientists and engineers are creating materials with unique properties and functions for use in a variety of applications. As manufacturing technology continues to develop and improve, we can expect to see even more innovative and advanced materials being produced in the years to come. The production of new materials is an exciting and rapidly evolving field, with researchers and engineers constantly pushing the boundaries of what is possible. In this article, we will explore some of the latest advancements in the production of new materials. One of the latest advancements in the production of new materials is the use of artificial intelligence, AI. AI is being used to model and predict the properties of new materials, allowing researchers to speed up the discovery process and identify new materials with unique properties and functions. This technology is being used in a variety of industries, including aerospace, electronics, and healthcare. Another advancement in the production of new materials is the use of biomimicry. Biomimicry involves studying and imitating the structures and properties of natural materials to create new materials with unique properties and functions. For example, researchers have developed materials that mimic the strength and flexibility of spider silk, as well as materials that mimic the self-cleaning properties of lotus leaves. Advanced materials such as metamaterials are also being developed. Metamaterials are engineered materials with properties that do not exist in nature, such as negative refractive index and invisibility. They have a wide range of potential applications, including in optics, electronics, and telecommunications. In addition to these advancements, new materials are being developed for use in energy production and storage. For example, researchers are developing materials for use in next-generation batteries and fuel cells, as well as materials for use in solar cells and other renewable energy technologies. Finally, the production of new materials is being driven by advances in manufacturing technology. For example, additive manufacturing is being used to create complex and intricate structures with a high degree of precision and accuracy. This technology is being used to create new materials with unique properties and functions, as well as to improve the efficiency and sustainability of the manufacturing process. In conclusion, the production of new materials is a rapidly evolving field, with new advancements being made all the time. From eye and biomimicry to advanced materials and energy production, researchers and engineers are creating materials with unique properties and functions for use in a variety of applications. As manufacturing technology continues to develop and improve, we can expect to see even more innovative and advanced materials being produced in the years to come. The production of new materials is an exciting and constantly evolving field, with researchers and engineers working to create materials with new properties and functions. In this article, we will explore some of the latest trends and innovations in the production of new materials. One of the latest trends in the production of new materials is the use of sustainable and environmentally friendly materials. With increasing concerns about climate change and the impact of human activities on the environment, researchers and engineers are developing materials that are renewable, biodegradable, and have a low carbon footprint. These materials include bioplastics, bio-based materials, and materials made from recycled waste. Another trend in the production of new materials is the use of smart materials. Smart materials are materials that can respond to changes in their environment, such as changes in temperature, light, or pressure. These materials have a wide range of potential applications, from aerospace and construction to healthcare and consumer electronics. Advanced manufacturing techniques are also being used to produce new materials with unique properties and functions. For example, 3D printing is being used to create complex structures with a high degree of precision and accuracy, allowing researchers to create materials with intricate and precise designs. Other advanced manufacturing techniques, such as nanomanufacturing and microfabrication, are also being used to create new materials with unique properties and functions. In addition to these trends, new materials are also being developed for use in energy production and storage. Materials such as perovskite and graphene are being used to create more efficient and cost-effective solar cells and batteries. While materials such as metal organic frameworks, MOFs, are being developed for use in gas storage and separation. Finally, the production of new materials is being driven by advances in materials science and engineering. Researchers are developing new techniques for synthesizing and characterizing materials, allowing them to create materials with precise and tailored properties. Advances in computational materials science are also helping researchers to predict the properties of new materials, speeding up the discovery process and allowing for the creation of materials with new and unique properties. Discover the manufacturing process lithium-ion battery manufacturing technology. The lithium-ion battery is one of the most important inventions of modern times, powering everything from smartphones to electric cars. The manufacturing process of lithium-ion batteries involves advanced technologies and innovative processes that are constantly evolving to meet the growing demand for these batteries. In this article, we will explore the production process of lithium-ion batteries. The first step in manufacturing a lithium-ion battery is to produce the cathode and anode. The cathode is typically made of lithium cobalt oxide, lithium manganese oxide, or lithium iron phosphate, while the anode is made of graphite. The cathode and anode are produced using a combination of chemical processes and advanced manufacturing techniques, such as electrodeposition and sputtering. Once the cathode and anode are produced, the next step is to assemble the battery cell. The battery cell is the basic unit of a lithium-ion battery and consists of the cathode, the anode, and the electrolyte. The electrolyte is a liquid or gel that allows the movement of lithium ions between the cathode and anode. The battery cell is assembled using a combination of automated and manual processes, and is sealed to prevent leakage. After the battery cells are assembled, the next step is to assemble the battery pack. The battery pack is a collection of battery cells that are linked together to provide the required voltage and capacity for the application. The battery cells are connected using tabs and wires and are often enclosed in a protective casing for safety. Once the battery pack is complete, the final step is to test and package the batteries. The batteries are subjected to a series of tests to ensure that they meet all safety and quality standards. After passing the tests, the batteries are packaged and shipped to the end user. One of the key benefits of lithium-ion battery production is that it produces less waste than traditional battery manufacturing. This is because the production process involves fewer toxic materials and fewer manufacturing steps. Additionally, many of the materials used in lithium-ion battery production are recyclable. One of the critical components of lithium-ion battery production is the electrolyte. The electrolyte is a liquid or gel that allows the movement of lithium ions between the cathode and anode. The electrolyte is typically made of a lithium salt dissolved in an organic solvent or polymer. The choice of electrolyte depends on the specific application of the battery, with different electrolytes offering different properties such as safety, stability, and performance. Another important aspect of lithium-ion battery production is the separator. The separator is a thin layer of material that separates the cathode and anode and prevents them from coming into contact. The separator is typically made of a porous polymer film that allows the movement of lithium ions while preventing the formation of a short circuit. The separator must be strong and heat resistant to ensure the safety and longevity of the battery. The production process of lithium-ion batteries also involves advanced quality control measures to ensure that the batteries meet strict safety and performance standards. During the production process, the batteries are subject to a series of tests, including visual inspection, electrical performance testing, and thermal stability testing. Additionally, the batteries are subjected to a series of abuse tests, such as overcharging and short-circuiting, to ensure that they are safe and reliable. One of the challenges of lithium-ion battery production is the high cost of materials. The cathode, anode, and electrolyte are made of rare and expensive materials, which can drive up the cost of production. Additionally, the production process requires a high degree of precision and automation, which can be expensive to implement. Despite these challenges, lithium-ion battery production is crucial for many industries, including consumer electronics, electric vehicles, and renewable energy storage. As demand for these batteries continues to grow, the production process will continue to evolve and improve, with advancements in materials, manufacturing techniques, and quality control measures. One of the most significant challenges in lithium-ion battery production is the need for a stable, safe, and efficient manufacturing process. The production process involves a variety of steps, including mixing and preparation of materials, coating of the electrode materials onto a substrate, and assembly of the battery cell. Each of these steps must be carefully controlled to ensure that the end product meets strict performance and safety standards. To ensure the quality of the battery cells, manufacturers rely on advanced techniques such as X-ray diffraction and electron microscopy to analyze the structural properties of the electrode materials. These techniques allow manufacturers to monitor the quality of the materials and detect any defects that could affect the performance of the battery. Another challenge in lithium-ion battery production is the need for a safe and reliable assembly process. The battery cells must be sealed tightly to prevent leaks, and the electrodes must be properly aligned to ensure that the battery performs optimally. This requires a high degree of precision and attention to detail during the assembly process. To ensure the safety of lithium-ion batteries, manufacturers must also consider the potential risks of thermal runaway. Thermal runaway can occur when a battery cell overheats, causing a chemical reaction that generates more heat and can lead to a fire or explosion. To prevent thermal runaway, manufacturers use advanced materials, such as flame-retardant electrolytes, and design the battery cells with safety features such as pressure relief valves. Another important consideration in lithium-ion battery production is the environmental impact of the materials used in the production process. Many of the materials used in lithium-ion batteries, such as lithium and cobalt, are scarce and expensive, and their extraction can have negative environmental impacts. To address this issue, manufacturers are exploring alternative materials, such as sodium and magnesium, that are more abundant and less harmful to the environment. One of the most critical factors in lithium-ion battery production is the choice of materials. The performance and safety of the battery depend on the quality and purity of the materials used in the production process. The cathode, anode, and electrolyte are made of a variety of materials, including lithium, cobalt, nickel, manganese, and aluminum. The choice of materials depends on the specific application of the battery, with different materials offering different properties such as energy density, stability, and safety. To ensure the quality of the materials used in the production process, manufacturers rely on advanced analytical techniques such as X-ray diffraction, atomic absorption spectroscopy, and inductively coupled plasma mass spectrometry. These techniques allow manufacturers to detect impurities and ensure that the materials meet strict performance and safety standards. Another important aspect of lithium-ion battery production is the manufacturing process itself. The production process involves a variety of steps, including mixing and preparation of materials, coating of the electrode materials onto a substrate, and assembly of the battery cell. The production process must be carefully controlled to ensure that the end product meets strict performance and safety standards. Operation mechanism: solar panel manufacturing technology. Solar panels are becoming increasingly popular as a source of renewable energy. The production of solar panels involves advanced technologies and innovative processes that are constantly evolving to meet the growing demand for renewable energy. In this article, we will explore the operating mechanism of solar panel production. The first step in the production of solar panels is the production of the solar cells. The solar cells are the basic units of a solar panel and are responsible for converting sunlight into electricity. The solar cells are typically made of silicon, a semiconducting material that is widely available and has excellent electrical properties. The production process of solar cells involves a combination of chemical processes and advanced manufacturing techniques, such as crystal growth and wafering. The process starts with the production of a silicon ingot, a long cylindrical piece of silicon that is sliced into thin wafers. The wafers are then treated with dopants, impurities that alter the electrical properties of the silicon, to create a p-n junction, a boundary between a p-type and n-type semiconductor. Once the solar cells are produced, the next step is to assemble them into a solar panel. The solar panel is a collection of solar cells that are linked together to provide the required voltage and capacity for the application. The solar cells are connected using tabs and wires and are often enclosed in a protective casing for durability. The operating mechanism of a solar panel is relatively simple. When sunlight strikes the solar panel, the solar cells absorb the photons and release electrons. The electrons flow through the wires and tabs, generating a direct current, DC, of electricity. The DC electricity is then fed into an inverter, which converts the DC electricity into alternating current, AC, electricity that can be used to power homes and businesses. The efficiency of a solar panel depends on a variety of factors, including the type and quality of the solar cells, the size and orientation of the panel, and the amount of sunlight that the panel receives. To maximize the efficiency of a solar panel, manufacturers use advanced technologies such as anti-reflective coatings, backside passivation, and selective emitter technology. One of the critical factors in the operating mechanism of solar panel production is the type of solar cell used. The most common type of solar cell used in solar panel production is the crystalline silicon solar cell, which is made of silicon wafers. However, other types of solar cells, such as thin-film solar cells, are also becoming increasingly popular due to their lower cost and flexibility. The production process of thin-film solar cells involves depositing a thin layer of semiconductor material, such as copper indium gallium selenide, CIGS, or cadmium telluride, CDET, onto a substrate. The thin-film solar cells are then assembled into a solar panel using similar techniques as crystalline silicon solar cells. Another important consideration in the operating mechanism of solar panel production is the efficiency of the solar panel. The efficiency of a solar panel is the amount of sunlight that is converted into electricity. The efficiency of a solar panel depends on several factors, such as the type and quality of the solar cells, the size and orientation of the panel, and the amount of sunlight that the panel receives. To maximize the efficiency of a solar panel, manufacturers use advanced technologies such as anti-reflective coatings, backside passivation, and selective emitter technology. These technologies improve the absorption of sunlight by the solar cells and reduce the loss of energy due to reflection and recombination. Another important aspect of the operating mechanism of solar panel production is the environmental impact of the production process. The production process of solar panels can have negative environmental impacts, such as the emission of greenhouse gases during the production of raw materials and the disposal of hazardous waste. To address this issue, manufacturers are exploring alternative materials and production processes that are more environmentally friendly. For example, some manufacturers are using recycled materials in the production of solar panels, such as recycled silicon and glass. To reduce their reliance on mining and minimize the environmental impact of the production process. Another important aspect of the operating mechanism of solar panel production is the testing and certification process. Solar panels must undergo a series of tests and certifications to ensure that they meet strict safety and performance standards. The testing process involves a variety of tests, including electrical performance testing, thermal stability testing, and durability testing. Electrical performance testing is used to measure the capacity, voltage, and resistance of the solar cells and the solar panel. The testing ensures that the solar cells and the solar panel meet the required performance specifications and that they are consistent across multiple panels. Thermal stability testing is used to measure the performance of the solar cells and the solar panel under extreme temperature conditions. The testing ensures that the solar cells and the solar panel can operate safely and reliably in a variety of temperature environments. Durability testing is used to simulate the effects of weather and aging on the solar cells and the solar panel. The testing ensures that the solar cells and the solar panel can withstand the effects of weather conditions such as wind, rain, and hail, as well as UV radiation and other environmental factors. In addition to testing and certification, the installation and maintenance of solar panels are also critical factors in the operating mechanism of solar panel production. The installation of solar panels must be done by qualified professionals to ensure that the panels are installed correctly and in a safe and secure manner. Maintenance of solar panels involves regular cleaning and inspection to ensure that the panels are operating at maximum efficiency. Regular maintenance also helps to identify any issues or defects in the panels and allows for timely repairs or replacements. Another important consideration in the operating mechanism of solar panel production is the integration of solar panels with other renewable energy sources and energy storage systems. The integration of solar panels with other renewable energy sources, such as wind and hydropower, can help to provide a more stable and reliable source of renewable energy. The integration of solar panels with energy storage systems, such as batteries, can help to store excess energy generated by the solar panels for use during periods of low sunlight or high energy demand. One of the critical factors in the operating mechanism of solar panel production is the cost. The cost of solar panels has decreased significantly in recent years, making them more affordable and accessible to a wider range of consumers. The cost of solar panels depends on several factors, such as the type of solar cell used, the efficiency of the solar panel, and the size of the panel. To reduce the cost of solar panels, manufacturers are exploring alternative materials and production processes. For example, some manufacturers are using alternative semiconductor materials, such as organic materials, to reduce the cost of solar cells. Other manufacturers are using advanced manufacturing techniques, such as roll-to-roll printing, to reduce the cost of production. Another important consideration in the operating mechanism of solar panel production is the scalability of the production process. As demand for renewable energy continues to grow, manufacturers must be able to scale up production to meet the needs of a wide range of industries and consumers. To address this issue, manufacturers are exploring new production processes and technologies that are more scalable. The process of inventing medical device manufacturing technology. The invention and development of medical device manufacturing technology have dramatically improved the ability of healthcare professionals to diagnose and treat a wide range of medical conditions. In this article, we will explore the process of inventing and developing medical device manufacturing technology. The process of inventing medical device manufacturing technology typically begins with identifying a need in the healthcare industry. This need may arise from a new medical condition or from an existing condition that is not being adequately addressed by current medical devices. Once the need has been identified, the inventor begins to develop a concept for a new medical device. This concept may involve new materials, new manufacturing processes, or new technologies that have not been used in the healthcare industry before. The inventor then begins to prototype the new medical device. Prototyping involves creating a physical model of the device to test its functionality and performance. This process may involve multiple iterations and refinements to ensure that the device meets the required specifications and standards. Once the prototype has been developed and tested, the inventor must seek regulatory approval for the device. Regulatory approval is a critical step in the development of medical device manufacturing technology, as it ensures that the device is safe and effective for use in the healthcare industry. The regulatory approval process typically involves submitting the device for review by regulatory agencies, such as the Food and Drug Administration, FDA, in the United States. The review process may involve extensive testing and evaluation of the device's safety, effectiveness, and performance. Once regulatory approval has been obtained, the inventor must then develop a manufacturing process for the device. The manufacturing process must be efficient, cost-effective, and scalable to meet the demand for the device. The manufacturing process typically involves a combination of advanced technologies and manufacturing techniques, such as 3D printing, injection molding, and automated assembly. The manufacturing process must also comply with regulatory standards and requirements to ensure the safety and effectiveness of the device. Once the manufacturing process has been established, the inventor must then market and distribute the device. This process may involve partnering with healthcare providers, hospitals, and other organizations to promote the device and ensure that it is used effectively. One important aspect of the process is the collaboration between inventors, manufacturers, and healthcare professionals. Collaboration allows for the exchange of expertise and knowledge, which is critical in developing medical devices that meet the needs of healthcare providers and patients. In addition to collaboration, the development of medical device manufacturing technology also requires significant investment in research and development. Research and development allow inventors and manufacturers to explore new technologies and materials, refine manufacturing processes, and improve the safety and effectiveness of medical devices. Another important consideration in the process is the regulatory environment. Regulatory agencies, such as the FDA, play a critical role in ensuring the safety and effectiveness of medical devices. Manufacturers must comply with regulatory standards and requirements to ensure that their devices are safe and effective for use in the healthcare industry. To address the challenges of regulatory compliance, manufacturers are exploring new technologies and manufacturing processes that can streamline the regulatory approval process. For example, some manufacturers are using digital models and simulations to test the safety and effectiveness of their devices before submitting them for regulatory approval. Another important aspect of the process is the impact on the environment. The manufacturing of medical devices can have significant environmental impacts, such as the production of hazardous waste and the consumption of energy and resources. To address this issue, manufacturers are exploring sustainable manufacturing processes and materials. For example, some manufacturers are using recycled materials and renewable energy sources in their manufacturing processes to reduce their environmental footprint. In addition to sustainable manufacturing, manufacturers are also exploring end-of-life management strategies for medical devices. End-of-life management involves the proper disposal, recycling, or repurposing of medical devices at the end of their useful life. Manufacturers are developing programs and partnerships to promote the recycling and repurposing of medical devices to reduce waste and maximize the lifespan of the devices. One important aspect of the process is the use of advanced materials and technologies. Advanced materials, such as biocompatible polymers and biodegradable metals, are designed to improve the safety and effectiveness of medical devices. Advanced technologies, such as artificial intelligence and machine learning, are also being used to develop smarter and more efficient medical devices. Another important consideration in the process is the customization of medical devices. Customization allows medical devices to be tailored to the specific needs of individual patients, improving their effectiveness and reducing the risk of complications. Customization may involve using patient-specific data, such as medical images and genetic information, to design and manufacture personalized medical devices. To address the challenges of customization, manufacturers are exploring new manufacturing processes and technologies that can produce medical devices on demand and at a lower cost. For example, some manufacturers are using 3D printing technology to produce customized medical devices quickly and efficiently. Another important aspect of the process is the training and education of healthcare professionals. Healthcare professionals must be trained to use medical devices effectively and safely to ensure the best possible outcomes for patients. To address this issue, manufacturers are developing training programs and educational materials for healthcare professionals. These programs and materials may include instructional videos, online courses, and in-person training sessions. In addition to training and education, manufacturers are also exploring the integration of medical devices with digital health technologies. Digital health technologies, such as mobile apps and wearable devices, can help healthcare professionals monitor patients and track the effectiveness of medical devices. The integration of medical devices with digital health technologies can also improve patient outcomes by providing patients with more information and control over their healthcare. For example, patients may be able to monitor their own health using wearable devices and communicate with their healthcare providers using mobile apps. One important aspect of the process is the testing and validation of medical devices. Testing and validation are critical steps in ensuring that medical devices are safe, effective, and meet regulatory standards. Testing and validation may involve a variety of tests, including mechanical testing, electrical testing, and biocompatibility testing. Mechanical testing is used to test the durability and strength of medical devices, while electrical testing is used to ensure the safety and reliability of electronic components. Biocompatibility testing is used to ensure that medical devices are safe for use in the human body and do not cause adverse reactions. To address the challenges of testing and validation, manufacturers are exploring new testing methods and technologies. For example, some manufacturers are using computer simulations and virtual testing to reduce the time and cost of testing and validation. Another important consideration in the process is the importance of design for manufacturability.